Hello everyone, and today we're going to be doing something called the Choco Challenge. So what is the chocolate challenge? In the description, I'm going to link this website, but basically it explains what the chocolate challenge is. But I can give you a little overview of what this chocolate challenge really is. The chocolate challenge is as follows. There are 3 tables. Table 1 has 1 bar of chocolate, table 2 has 2 bars of chocolate, and table 3 has 3 bars of chocolate. There are 30 students in total who want to have a share of chocolate. Students go one by one into the room and pick which table they would like to eat from. The aim is for each student to pick which table will supply the student with the most chocolate. Yum! So let's think of this as a diagram. If we have 3 tables with chocolate bars on them, of course we know table 1 has 1 chocolate bar, table 2 has 2 chocolate bars, and obviously table 3 has 3 chocolate bars. See? So let's say student 1 walks in through the door, okay? This is the door and student 1 walks in, okay? Now, student 1 has to think, which table is the best table for him that he gets the most chocolate? Table 1 will give him 1 whole bar of chocolate, table 2 will give him 2 whole bars of chocolate, and table 3 will give him 3 whole bars of chocolate. So obviously, student 1 is going to go to table 3. So we see that student 1 is over here, and now student 2 walks through the door. And by the way, disclaimer, you might have thought, oh wow, that was the easiest problem in my whole entire life. Okay, I agree. But the thing is, as it goes on, the more people that come, the more harder it gets, and you'll see. So if student 2 comes, if student 2 goes to table 3, then he is going to have 1.5 bar of chocolate, okay? Which is, okay, that's cool. So student 2, if he goes here, 1.5, he'll get that much. But if student 2 goes to table 1, as we see over here, student 2, I think I said that, then he's going to get 1 bar of chocolate. What if student 2 decides to go to table 2? He'll get 2 bars of chocolate. Which one is the biggest number out of all of these? Of course, 2. So student 2 is going to go to table 2. See how that got a little bit harder? Of course, we're not going to do this 30 times, but I'm just trying to give you an idea. What if student 3 walks in the door? And now this is going to get even harder. It's not going to be hard, but it's going to be harder than the other ones. Student 3 could get 1 whole bar of chocolate if he goes to table 1. He can get 1 whole bar of chocolate if he goes to table 2 as well. And if he goes to table 3, he'll get 1.5. So it's pretty obvious which one's bigger. 1 or 1.5. He'll go to table 3. Let's do student 4 and student 5, and then I think you'll get the hang of it. Student 4 can go to table 1 for 1 bar of chocolate, can go to table 2 for 1 bar of chocolate, can go to table 3 for 1 bar of chocolate, exactly. So now when you come to these scenarios, you can actually just choose randomly. Student 4 will get 1 bar of chocolate whichever table he goes to. Because if he goes to table 1, there's only 1 bar of chocolate. If he goes to table 2, student 2 is going to have 1 bar of chocolate himself, and 4 is going to have 1 bar of chocolate. Remember, students have to share the chocolate equally on the table. And if he goes to table 3, student 1 gets this, student 3 gets this, and student 4 will get this. So that's why student 4 can choose wherever he goes to. But I personally would just put student 4 in table 1 because no one has gone there yet. But if you want to be brutal, I can tell you this. Me and the other mathematicians did this before. We were role-playing this. Kaushik was actually student 2. I was student 4. If I want to be brutal, I can actually go to table 2, get 1 bar of chocolate, and also take away Kaushik's 2nd bar of chocolate. If I go to table 1, Kaushik has 2 bars of chocolate. If I go to table 2, he has only 1 bar of chocolate. And in both cases of scenarios, I get 1 bar of chocolate. So it's good for me and it's bad for him. And of course, it's the same scenario if I go to table 3. Okay, so let's go through this one. Student 5 walks through the door and he sees 2 people at table 2, 2 people at table 3, and no one at table 1. If he goes to table 1, he gets 1 bar of chocolate. If he goes to table 2, he will get... Now, if you think about this, this is a bit hard. But actually, there's 2 bars of chocolate, and there's 3 people. So we're going to do 2 divided by 3, which actually is think about it. It's oh yeah, got it. It's 0.6 repeater. So it would not repeater. I guess if you go deeper, it would be 0.66666, many sixes, and then there would be a 7, and then it would be crazy. But the point is that 2 divided by 3, you would know that if you turn that into a fraction, we're actually going to get a fraction of 2/3. So that means if we picture the 2 bars of chocolate, we're going to split it into thirds. It's not exact thirds, but bear with me. Student 4 is going to get this part and this part. Student 2 is going to get this and this, and student 3 is going to get the remaining, this and this. So that's why they all get equal amounts of chocolate. So it is 2/3. So if he goes to table 2, he gets 2/3. And now if we go to table 3, we will get 1 whole bar of chocolate. So we can either go to table 1 or table 2. Where would you like to go, anonymous person? Jake?
Table 3.
Table 3. So student 5 is going to go to table 3. Here we go. Alright, so now that we've gone through a few examples, let's actually just speed run this and let's see what we get. Student 6 to table 3. Student 7 to table 3. Student 8 to table 2. Student 9 is the first one to go to table 1. Student 10 is going to table 3. Student 11 goes to table 3. Stranger Things. Student 12 goes to table 2. Student 13 to table 2. Student 14 goes to table 1. Student 15 goes to table 3. Student 16 goes to table 3. Student 17 is going to go to table 2. Student 18 goes to table 3. Student 19 goes to table 3. Student 20 goes to table 2. Student 21 goes to table 3. Okay, so now student 22 enters the room. And let's take a break. Look at what we have conjured over here. Oh my god. That is crazy. That's a lot of people. But that's 21 in total. But at this point, the questions have turned lots and lots harder. So let's walk through this one. Student 22 has to be a bit smart over here right now. With these kind of problems, when it gets harder, we need to evaluate and see what fraction of chocolate each table will supply student 22. If we go to table 1, there is only 2 people at table 1. Student 9 and student 14. If student 22 joins, he'll get a third of a whole chocolate bar. Okay, that's very tasty. What if student 22 goes to table 2? There's 1, 2, 3, 4, 5, 6, and 7 people already sitting at table 2. So what do we do here? If student 22 goes there, there'll be 8 people in total sitting at table 2. And we already know there are 2 bars of chocolate in table 2. What we're going to do is we're actually going to write the fraction 2/8. Now, that's not the fraction everyone gets, but we do know that's the problem we need to solve. What do I mean? 2/8 actually just means 2 divided by 8. And with that, we can get another fraction that will actually tell us what fraction the amount of students would eat, including if student 22 went to that table, okay? 2 divided by 8 it seems difficult because it's not 8 divided by 2. 8 divided by 2 is 4. That's easy. But this, you're asking yourself, how many times does 8 go into 2? That does not work. So you need to do some mathematics. And the way you do long division like this, you're going to put a 0 here, and you're going to put a decimal point. Basically, you put a 0 here, and you trade it for a decimal point. Now we'll ask ourselves, how many times does 8 go into 20? It actually goes 2 times, because 8 times 2 is 16. We can write that here. 20 minus 16 is 4. Oh, you don't have space. And then if we add another 0, because we already gave the decimal, we don't have to give anything else for another 0. 8 times 5 is going to get you 40. So 0.25. And we know that is actually 25/100. And that is actually the fraction that everyone would get if student 22 came to table 2. Yet, we actually know 25/100 equals a quarter. So we can tell that a third so far is better. So far it's better for student 22 to go to table 1 instead of table 2. But how much chocolate does student 22 get if he goes to table 3? Okay, so let's count. There is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 people, I believe, already sitting there. Now, if student 22 goes to table 3, there will be 13 people sitting at that table, meaning there's 3 bars of chocolate, and we're going to do the exact same strategy. We are going to do 3 divided by 13 because there's 3 bars of chocolate and 13 people are going to share it. So let's do this. We know that we have to add a 0 here. We're going to trade that for the 0 and the decimal point. And now we ask ourselves, how many times does 13 go to 30? 2 times over here, as we can see, it goes up to 26. So if we put a 2 over here and we put 26 down below here, we're going to get a 4. And now we can put another 0, and we're going to do 13 times 3. Let's see if that will be 40, because we need to find something that will equal to 40. No, that doesn't. But 39 is close, so we're going to put 3, and we're going to put 39 underneath. And 40 minus 39 is 1. So you still go down on that trail, but 2 digits for the decimal point is good enough for us. So now we have all the fractions that student 22 will get. We know table 1 will give more chocolate than table 2. What about table 1 versus table 3? We know that this is actually smaller. 23 over 100 is actually smaller than 25 over 100, and that was a quarter. So that easily tells that student 22 should go to table 1. The third person out of all of these people to go to table 1. Okay, see how they get harder? All right, let's keep speed running this. Student 23 goes to room table 2. Student 24 goes to table 3. We're 83.33333% there. Student 25 goes to table 3. Student 26 goes to table 2. Student 27 goes to table 3. Student 28, it's a funny thing. Student 28 will actually get a fifth of a chocolate bar, whichever table he goes to. This actually hasn't happened out of all the students. So, what are we going to do? We need to randomize it. Okay, let's see this. Generate. Okay, looks like student 28 is going to go to table 2. Okay, and then student 29 goes to table 1. P.S. Student 29 also could have gone to table 3 and gotten the same amount of chocolate. But let's make student 29 the 4th person to go to table 1. And finally, we have the last student, student 30. He walks into the room seeing 29 people sitting at 3 tables in total of 7 bars of chocolate. Which table will give him the most chocolate he can eat? If he goes to table 1, he'll get 16% chocolate, okay? Because that's 16 over 100. If he goes to table 2, he will get 18% chocolate because that's over 100. And if he goes to table 3, he will get 20% chocolate because it's 20 over 100. So student 30 goes to table 3. Let's check out the stats. There's literally 4 people at table 1, 10 people at table 2, and 16 people at table 3. Yes, everyone, that was a very difficult challenge, but we got through it. So, yeah, maths is fun, but you need to do a lot of work. It makes sense. And this also is actually how much math work and planning I had to do on this maths page from my maths workbook. So yeah, as I mentioned, it's filled with all the mathematical work I had to do, as well as all the planning of this video. So yeah, all I ask for you is to enjoy the rest of the MHS Maths Group YouTube channel and enjoy this video as well. So yeah, thanks and goodbye. Whee!